1, fight!
Count. BC.
Unit 1, factor out the ones. All these units cooking up, they my sons. Definition of the limit, yeah, I'll tell you. As X approaches a number, what's the Y do? What's the Y do? Turn it up like how you. Killer wasn't real, this ain't no spiel. Like a removal continuity, yeah, I can deal. Test it from the left, test it from the right. See the FRQ and the fight or flight. We about to hit it, but we never hit it. That's the unit limit. Oh my god, I'm scamming, but I never do it, so I say screw it.
Average instantaneous, you should probably take the rates. Power rules the OG here, it's like a piece of cake. Derivatives get tricky when we're talking about trig. Cosine, sine, and tan, I think you get the gig. What you know about product rule, we have the quotient too. Second year we learned it, thanks Miss Wilkinson, my boo. Derivative of LNS, it's easy to succeed. E of X my favorite, like my god Joel and B.
We go into Unit 3 with Curly, open up that packet. Starting with chain rule, spot the inner, then attack it. Implicit differentiation onto U next. Take the function and derive with respect to X. Deriving the inverse can get a little tricky. Take the right steps and solve it in a jiffy. Mastering derivatives, no shortcuts are fake. Miss Wilkinson, remember that double I hit off Jake.
Unit 4 related rates, only differentiate. Find the max or find the min. You know max just hit a bin. Ladder shadows make the fence. Cylinder and find its tense. Optimize the area to solve a problem aerial. Moving towards the application. Diffy low acceleration. Tangent to approximate. I call it L of X is great. I take the Y and find the prime. Just plug and chug. We hack a mime. Include a point that's kind of close. No calculator. It's just gross. And for the limit sitting here, each method indeterminate. We got a special case for that. Call a hot beetle just to solve it. Step the top right from the bottom. Take dy dx of all them. Flip them back and keep them moving. Might need one more just to prove it.
And MPT, they both need continuity. In my dresser, I got jewelry. I got this thing down to a T. Straight up A's on my test. The first derivative test, second derivative test. Yes, to max, I'm the best. Can't forget optimizations like 4 but worse. Drawing a picture won't help you just like this verse. Set that F prime equals 0. You're gonna need to do this. It would really help if max would just give me one more kiss. You can find the area under curve by using Riemann sums. Left, right, middle, trapezoid. Truth is that it sucks. To get a more accurate number, you're gonna need an integral. Plug into the integral, you're gonna need an interval. It's time to integrate that thing, yeah, we got linear partial. We got tabular, the good at parts a hero like Marvel. You need to try to use so if you can avoid the struggle. But you need to use parts if you get into trouble. Nah, bro, I hate you, so yeah, the thing is ass. Finding you, to you, bro, I'll be Oris, I'll leave class, ayy. The fundamental theorem ain't got nothing on me, ayy. To break the YDS, you're gonna get the original, homie. Yo, it's Jack McGee on the beat. Alpha, Beta, Charlie, now we're going over our worksheet. Copper integrals, yeah, we're testing for divergence. Is it a good time to say have bad conversions?
We're here in Unit 7, yeah, it's my turn on the speed. Slope fields in this unit, such an easy FRQ to complete. Differential equations, yeah, they in this too. Separate the variables, that'll give you a clue. Integrate them next, plus C, we'll keep it general. If you want specifics, the IC is the perfect hypothetical. Now my flow starts to slow, like a curve that's logistic. I'm approaching my limit, that's the main characteristic. My bars are fire.
You approve the dance.
Yes.
But don't forget Euler, his approximation method is required.
Average value of a function, I don't need no introduction. Roll the curve round the x, round the y will come up next. Is the equation to x equal? No, this method is the sequel. Outer r minus the inner, square it up and it's some dinner. Area between two curves, this is getting on my nerves. This circle cross section's gonna need a test curve.
Yo, we MVCs, starting Unit 9, using equations to make curves align. Mike is like these functions, smooth and fine. From circles to spirals, functions unwind. Parametric curves make me feel the pain. Sine and cosine are the main. To find new values, use differentiation. Max up next like a reincarnation. Polar coordinates, R and theta on the scene. Switching from X and Y, blown to smithereens. R equals F of theta, plotting points in a plane. Angles and radii, making the graphics plain. Vector valued functions like the right side of the room. We sweep in the left, somebody get the broom. Matt's on the delta with his buddy Chad. He can't keep getting away with this in undergrad.
Final round. Fight.
Don't want it to end, but it's time for Unit 10. If the first method don't work, you gotta try it again. All these convergence tests got my brain divergent. I call up my good friend Verge and I get to working. If R is less than 1, then I know to find that sum. But if P is less than 1, to continue would be dumb. Absolute convergence, or maybe it's conditional. Taylor polynomials, I know they're untraditional. You take a point, derive it, and divide by a factorial. That's not the only one. Maclaurin's an additional, centered at 0. I know it sounds quite fictional. Its error so small, it almost seems criminal. To find that error, call Lagrange, don't be so oppositional. A function as a power series, sure to be attritional. Derive or integrate the function, now it's intuitional. Our love for calculus, it's surely dispositional.